In this lesson, we're going to be solving this problem. This problem is under the strength of material. So here, the problem statement reads as follows. A brass pipe with the outside diameter 45 millimeters and the inside diameter 35 millimeters is placed concentrically over a round steel rod 32 millimeters diameter and 420 millimeters long. Rigid plates are fitted to the ends. Determine the stresses induced in the rod and the pipe due to a load of 60 kilonewtons. Let us extract data from this problem. We've got the diameter here, 45 millimeters of outside diameter of a brass. Then we've got the diameter also here, the diameter also here. Then we've got the length of the pipe, then force in this Young modulus. Here, let us say now this diameter, because this diameter of the pipe, there are two diameters. We'll say this, the bigger one. Say this one for bigger one. Say this is 45 millimeters. Then this, so the smaller one, it is 35 millimeters. Then this is for a steel rod. This one, it is separate for a steel rod. This board is for the brass. So that's why I separated it like this. This is for this diameter is for the steel. This is for a brass. It's for a brass. This is for the steel. It is 32 millimeters. Then we've got them. The force here, it is 60 kilonewtons, which is 60 times 10 to exponent 3 newtons. Let us try now to calculate. Our goal here is to calculate the stress for both sides, the stress for brass, the stress for a steel rod. When I use the change in length formula, which will say the change in length of a brass is equal to a change in length of a steel. Then from here, let us first calculate the area for this. Let's calculate the area for the brass first. It is pi divided by 4. Then we open the bracket. Then we'll say the bigger diameter squared minus the small diameter. Then close. Then here it is pi. Then we put the numbers here. The diameter, it is 0.045. This diameter, it is 0.045 meter. This one, it is 0.035 meter, like this. Then this one is 0.032 meter. Then here we put squared minus this is 0. This one is this one 0.35 squared like this. It's gonna give you 6.28 times 10, 6.28 times 10 to exponent negative 4 meter squared. That's the area for a brass. Now let's calculate the area for a steel. Then we'll say pi. Then we put this area here. It is 0.032 squared divided by 4. We get the area here to be 8.04 times 10 exponent negative 4. That is meter squared. That's the area for a steel part. Then because now we have the area here, this it is a force times the length divided by area times Young modulus. Then this part here, it is also force times the length divided by area times Young modular. This part is for a steel part. This part is for a brass. It is like this. Then let's proceed. Then we'll substitute here. Since we know that this compound it's got the same length, that means the length will remove the length here because the length are the same on both sides. Length for the brass is equal to the length for the steel. The length will remove the length here. Then let's proceed. Here, since we know that when you want to calculate the stress is a stress equal to a force over. So when you're looking at this stress formula, this part it's exactly this part and also this one. So instead of this part, we'll put the stress here for the steel pipe, and this side the stress for the brass, like this. Since you know this, the Young modulus here, it is for the brass. Here on this side is for the steel. It is the stress for the brass divided by Young modular for the brass is equal to this side, the stress for the steel divided by Young modulus for the steel. Then here, let's leave the stress of the brass this side. Say the stress of the brass is equal to, then we cross multiply, this go this way, the Young modulus for the brass times this stress for the steel, then divide by the Young modulus for the steel, like this. Then when you proceed here, Young modular for the brass, it is Young modular for the brass, it is 100. Then we can put this times 10 to exponent 9, it's a gigapascal. Then divide by the Young modulus for the steel, it is 200 times 10 to exponent 9. Then this times the stress for the steel. These cancel the same. Here, the stress for the brass is equal to, then when you solve this, it gives 0.5. Then you put this stress for the steel. Then this is equation. The force here, this one is a total force, this is a total force. To get this total force, that means you add the force for the brass and the force for the steel to get this total force. That for this, to get this total force, you have to add the force for the brass plus the force for the steel, like this. Then here, because we have the force here, the total force here, it is 60 times 10 to exponent 3. Then is equal to the force here for brass. Then since you know that from this formula, to rearrange this stress formula to make force subject of this formula, it is times the area. That means instead of this force, we'll put this, then let us write it. It is a stress for the brass times the area for the brass plus same here, the stress for the steel times the area for the steel, like this. Then we have the area here, we have the area. It is 60 times 10 to exponent 3 is equal to, we put back the stress for the brass, then the area here for the brass here, go to this side, you put this stress for the steel, then the area for the steel, it is this area, it is 8.04 times 10 to exponent negative 4, close bracket. It is like this. Then from here we proceed 60 times 10 to exponent 3. This is our force. Instead of this, we put this. It's because it's equal to a brass. This one is 0.5 stress for the steel. Then this, put this back, 6.28 times 10 to exponent negative 4, then plus stress for a steel also, then 8.04 times 10 to exponent negative 4, like this. Then this, all this, it's gonna be stress for a steel is equal to 60 times 10 to exponent 3 divided by 1.118 times 10. It is 53667.262.97 Pascal. That is the stress for the steel. It is 53.6 megapascal, like this, when you convert it into Pascal. Now we have to find the stress for the brass. We'll work on this. It is a stress for a brass. Then to find the stress for the brass, we're gonna use this one. So it is 0.5. Then stress for the steel, this here, we found it here, it is 53.6 times 10 to exponent 6, like this. This, it is same as this and also same as this. Then 2683.3631.48 Pascal. This, it gonna be 26.8 megapascal. That is the stress for the brass. From the problem statement, we are required to find the stresses here. We found that the stress, a pipe is a brass. So the stress for the pipe and also the rod here, the stress for the rod it is a steel. Then you put that stress, we got it now. It is 26.8 megapascal. And here it is 53.6 megapascal.